Hello everybody, welcome back to Virtual School Physics is Fun. So today Puan Liao is going to explain about concave lens. Okay, concave. Use the word cave here to help us to remember the shape caves in, right? This is a concave lens. So the surface here caves in, alright? So a concave lens has got this shape. A concave lens is a diverging lens. What do you mean by diverging? Okay, it means all parallel rays will be refracted by the lens, and the refracted rays are all spreading out. They are all diverging. Okay, they go further and further away from each other, and they are diverging from, if we trace back with these dotted lines, they are all diverging from a point here, which is called focal point. F, focal point. Okay, let's learn some important points and concept of concave lens. First and foremost, an axis that cuts the lens into two horizontally is called a principal axis, right? And another axis that cuts the lens vertically is called optical axis. So the optical axis and the principal axis intersect at the center of the lens called optical center, O. So O is the optical center. Just now we say focal point, right? All parallel light rays diverge from a point called focal point. So this focal point is on the principal axis, focal point F. Now, capital letter represents point. Capital O, capital F. The distance between focal point and optical center, so FO, this distance is called focal length. And we use small f, small letter f, to represent distance. Clear? Okay, let's look at three rays rule of concave lens. We have already learned three rays rule for convex lens. So now concave lens. Concave lens, I also name these three rays as ray P, ray F, and ray O. So ray P means the incident ray is parallel to the principal axis. So P stands for parallel. So ray P, incident ray that is parallel to the principal axis, will be refracted, diverge from focal point. Okay, so we draw dotted lines so that we can trace this refracted ray to get the focal point. And then the second ray, I name it as ray F, simply because this incident ray passes through F. All right, passes through F. Of course, it does not actually pass through F. We trace it so that we can draw this ray F. So we trace this with dotted lines. So the incident ray, ray F, is refracted parallel to the principal axis. So again, it is the opposite of ray P, similar to concave lens, convex lens. So ray P and ray F, they are exact opposite to one another. For ray P, the incident ray is parallel. For ray F, the refracted ray is parallel. Okay. The third one is ray O. Ray O is a ray that passes through the optical center O, and it just goes straight through without bending. Okay, so we learn up ray P, ray F, and ray O. See the difference between concave lens and convex lens. The ray P, ray F, and ray O of concave lens and convex lens, they are different. Okay, for convex lens, it's refracted towards F. For concave lens, it is refracted from, yeah, from F, diverge from F. All right. Now with these three rays, we are going to draw image. All right. So let's look at this brown ray. So what ray is this? This is ray P. So ray P, because it's parallel to the principal axis, so ray P is refracted, diverge from F. Okay, so we trace back from F. So we know the angle of the refraction. Then we can draw ray F. So this purple ray is ray F because it passes through F. All right, so it is refracted parallel to the principal axis. And the third ray is ray O. The blue ray, you see, it passes through O and it goes straight through. So I have ray P, ray F, and ray O. Okay? Now, where is the image? Image is formed at the intersection of refracted rays. So you look at these three refracted rays. This one, and this one. Do they intersect here? No, they are diverging. They are going further and further away from each other. The more we lengthen, we draw them, they are going to go further apart. So they are diverging from one another. So where do they intersect? So to get the point of intersection between this refracted ray, so we trace back. So you see, we trace back with dotted lines. So this one we trace back, and this we trace back. Okay, this one, of course, is the same path, so we don't have to trace back. It is this line. So you see, these three refracted rays, they intersect here. Therefore, this is the place where the image is formed. Okay, so with these three rays, we can draw the location of the image. We can draw the image. All right, so you can see from here, the image is upright and it is smaller than the object. And if I put a piece of paper here, I will not be able to see the image on the paper. I do not see the image on the paper. Yeah, but I do see the image. Okay, so this type of image is virtual. In fact, we see the image from here and we see the image is like on the lens. Yeah, but we don't see the image on the screen or on the paper. Okay, so if I have the object placed here between F and 2F, so I draw ray P. So ray P diverge from F, and this is ray O. So the two refracted ray diverge. So I trace back. So I get the intersection. So this is where the image is formed. So you see the image is virtual, upright, and diminished. All right. So if I put the object between F and 2F, yeah, at this distance between F, this is F, and this is 2F, we see that the image is virtual, upright, diminished. What if I put the object elsewhere at different position? Now let's study the characteristics of concave lens if the object is placed at different position. Okay, first and foremost, if the object is at the far distance, U is the object distance. If I put the object further away from 2F, so U is more than 2F. So we draw ray P. So ray P is diverge from F. This is ray O. Okay, go straight through. So the two refracted ray trace back. So they intersect here. So this is the image. So the image is virtual, upright, and diminished. Now the second case, if I were to bring the object nearer to the lens, I place it between F and 2F. So now U is more than F and less than 2F. Same way, I draw ray P, diverge, ray O, go straight through, intersection of the two refracted ray here. So this is the image. So again, you see, you compare the image at this position and this one. Aren't they similar? So they are similar. How are they similar? They are virtual, upright, and diminished. Okay, so two cases already. What if I bring the object even nearer to the lens? I place it less than F. So now U is less than F. Alright, same way, I draw the ray P, ray O, and here I can draw ray F also. So these three refracted rays trace back, trace back, trace back. So they meet here, they intersect here. So the image is formed here. So you see, image is again virtual, upright, diminished. Therefore, from these three cases, we can make a conclusion by saying that no matter where the object is, yeah, the position of the object is not important. No matter where the object is, the image of concave lens is always virtual, upright, and diminished. Okay, so the image of concave lens does not depend on the object distance. No matter where you place the object, the image is all similar. They are always virtual, upright, and diminished. Different from convex lens. Yeah? Convex lens, the image formed by convex lens depends on the position of the object. Okay, so the only difference we can see is if the object is nearer to the lens, as you can see from position 1 to position 2, 3, 4, 5. So corresponding, the blue one is the image, corresponding image of 1, 2, 3, 4, 5. Yeah. So how are they different? They are still virtual, still upright, and still diminish, yeah, still smaller than the object. Only difference is the nearer the object is to the lens, the size of the image is slightly increases. Yeah, it's slightly increased, but it is still smaller than the object. It's still diminished, but the size increases. Okay, so we conclude by saying image of concave lens does not depend on the object distance. It is always virtual, upright, and diminished. And image size increases when object distance decreases. I repeat, image size increases when the object distance decreases, but it is still a diminished image. It's not bigger than the object. It's still a diminished image. Okay, all right, so that's all for concave lens. So we will continue with other topics later on. Watch out for more video. All right, thank you.